everyone. Welcome to our meetup. Thanks so much for coming. I'm Sylvia. I'm the marketing director of Tom Sawyer Software. I just want to give you some logistics. So there's food and drinks back there in case you haven't had anything already. Bathrooms are actually behind that section right there in the corner. With that, I'm going to turn it over to our technology director, Kevin Madden. He'll be the presenter for this meetup today.
Thank you, Sylvia. I'm Kevin Madden. I'm the Director of Technology for Tom Sawyer Software. Thank you for coming out to the meetup today. I just have a quick question. How many of you are familiar with Tom Sawyer Software at all? Okay. So a lot of new people to Tom Sawyer's products and Tom Sawyer's visualization techniques. I'll go to our next slide here. Just a little bit about me. I have over 20 years of software engineering experience. I did a startup company in about 2006 where I did enterprise search visualization, where I applied graph visualization techniques to search results and coupled that with enterprise search and distributed computing frameworks. As the CEO, I worked on the venture rounds and all those kind of things, setting up the corporate structure and incorporating and coming up with the engineering plans and business plans and all that kind of stuff. Klooster was acquired by Tom Sawyer Software in 2009. So I have both corporate experience and software engineering experience. Prior to that, I was one of the lead architects of Embarcadero Technologies database administration products, DB Artisan and Rapid SQL. And I did some other work on their ER diagramming system, which creates ER diagrams for databases that describe the schema behind the data. While I was at Embarcadero, Tom Sawyer, Embarcadero, and Sun Microsystems did a joint project together to implement the UML modeler for NetBeans. And it was the keynote delivered by James Gosling, the father of Java, at the 2003 Java 1 trade show here in San Francisco. So it's quite an honor to have the father of Java demoing your software in front of the entire Java 1 trade show. Very important. I also held some senior roles of engineering at Informix database company at the CTO office under Dr. Stonebreaker, who is he's a professor of computer science at the University of Berkeley. At Informix, I did geo data visualization on a product called Visionary, which would take data warehouses and create business analytics applications on top for creating corporate dashboards so you can visualize the information contained in that and create actionable items for corporations. I also worked on the AIX system at IBM's T.J. Watson Research Lab in New York for a year or two when I was in high school. So, with that, I'll continue on here. I'll get to the bread and butter. So, a little bit about Tom Sawyer. Tom Sawyer Software is a premier provider of high-performance visualization and analysis applications. It's based out in Berkeley. It was started by my older brother, Brendan, and he's right over there. And so I've been working at Tom Sawyer since the early 90s. I worked from right after college till about the late 90s. And then I went on and worked with Informix and Embarcadero and some of the Symantec and a few of those other companies. So Tom Sawyer, main focus is graph theory, graph visualization. Mainly started out as a network visualization company for working for Sun Products, working on SunNet Manager and products like that, which allowed the internet to be visualized and managed. So some of our corporate customers, like General Electric, Hewlett-Packard, IBM, Cisco, NASA, TIBCO, Airbus, and BP, and some other large-scale enterprise companies. So we've been embedded in large-scale enterprise deployed applications for many, many years. So a little bit about us. Next slide. So today's agenda, we're going to cover a few examples using our new product called, Tom Sawyer Perspectives. Tom Sawyer Perspectives basically allows you to visualize data and convert data into graphs and other kinds of data, and to visualize it and rapidly build applications that allow you to do analysis and other kinds of visualization techniques so that you can present it to the user in a short order. It used to take, data integration used to take quite a while. Like you'd have to bring in custom engineers and you'd have to spend weeks or months trying to get data to federate data together. And then to create a web app or something like that, it would take you a long time of custom coding, starting from scratch. So what we've done is we have a rule-based, data-driven front end, which allows the application framework to be separated from the deployment of the application. This allows us to move the application between platforms, so we can go from the desktop to the web without any custom. Is this a little better? We can go between frameworks, whether it be like desktop, .NET, or the web, and different web technologies as well, whether it be JSP or SWT or other web frameworks like HTML5, which allows animation inside the browser. So as browsers have gotten more, have supported direct drawing models, we've gotten the ability to add animation and interactivity to web applications using graph rendering techniques. So I'm going to go over a few examples. Sorry. First thing I'm going to show is what we call our Deadliest Earthquakes. I'll switch over. This is our Tom Sawyer Perspectives designer application. So what I'm going to show is, let's see, I have a little PowerPoint file here that I have just a little bit of data in it. I have some years, the magnitude of an earthquake, so the earthquakes that are from 8.0 to 9.9, and so on. So we have an estimated number of deaths on this column, the magnitude, and some totals. So, and we have a few other little bit of data. This can all come out of a SQL query, or it can come out of a spreadsheet, or any kind of XML, or different types of data sources. And so for us, it's just simpler, just put it in a spreadsheet so it's easy to present. But most of the time they come out of a relational query, or a NoSQL-based query, or from just a file system, or from API-driven, which means that you can directly call the code to populate the models. So this is the data set that I'm going to use. And from that data set, we create what we call our schema. So usually the database usually has a schema, which is like the table systems underneath, and the relations, the primary and foreign keys, and that kind of stuff. We create a UI-based schema, which allows us to reduce the amount of overhead and allows us to manipulate the schema on the fly. So, and in this case, we have the notion of an earthquake. Something happened. It has a date, location, coordinates, the number of deaths, and a magnitude. Okay? So this data all comes in from what we call an integrator, which I'll show you allows you to, it just points right at my spreadsheet, okay? And then we have what we call our bindings. So now once I have my schema, I want to bind it. So I need to bind it to the columns that come in out of the query or come off the spreadsheet or whatever. So I have my ID, matches to this column, the date matches to that, the location, and so on. And so once I have the data populated between the schema and the model, I'm able to create views on top of that. So in this case, I have a map, which is like a Google map. I have a tree, which is a tree control. I have a chart, and I have another chart. So one's called fatalities, and one's called statistics. So I'll just run it really quick, and I'll deploy it to the web. So you can deploy it to the desktop. You can deploy it as an image map, or an image map is like the old school Google Maps where you can tile, and there's no client necessary. So you can run on older browsers like IE6 or like that, right? So, and all those other new ones. So HTML5 is the one that supports direct rendering models. So this entire web front end was developed just generated from that one little piece of data. And in this case, we have a series of bar charts that show the magnitude so we have difference between 1900 to 1929, 1930 to 1959, 1960. So I can reduce this set by just clicking on these. I can see which years the earthquakes are happening. So you can see how they're distributed across the world. So each time there's an earthquake, it shows where the earthquake is located. And in this case, there's a flag, and then there's some push pins. So let's see what those mean. So I'll go back to my designer, and I'll go into my map, and I'll see how that happened. So I have my definition. So when I see an earthquake in the data, what do? Okay, I want to add a marker to the Google map. So basically we say add a marker, that's like a push pin. It says, we have this little scripting language which allows you to interpret on top of the data that comes in. So if the magnitude, if the cluster number is bigger than some ID, okay, then I want to set the marker properties. Okay, here's my condition. If there's a cluster of earthquakes, I want to use a push pin. But I want to change that, and I want to show a red push pin, because it's like a cluster of earthquakes. It's like an earthquake storm. And in the other case, I wanted to show a little blue flag for a single instance of an earthquake. Okay, I changed it, let's run it. So now I can see the clusters of whether there's earthquake storms or the single event earthquakes. So now I want to reduce the data. I don't care about the earthquakes in the early 1900s, unless it's in San Francisco. And that's when that happened. Okay. So I can see the recent earthquakes between 1990. So now I want to interact I can see how many people have died. And then when I zoom down on it, this is the one that happened. But I want to see more information about this instance of this earthquake. So, okay, I need to see more instance data. So I want to add properties. So I can say, okay, I need a new view. Okay, I want a chart, or I want an inspector. Just a sec. Okay, so I created a little property window. Okay, I'm going to drive it from the earthquake data. Let's see. Inspector. Okay, earthquake. Okay. And I'll select them all. So that shows that I'm going to see the coordinates, the date, deaths, and the ID. I don't really need the ID, so I'll delete that. And the year interval, don't need that. Okay, don't need that. So now I'll run it.
Okay. So now, if I can change the filters that I want to see only earthquakes between 6.2 and 7.8. I'm starting to get less and less. Well, what's this guy? Okay, so 316,000 people died right here. And then see, all of a sudden down here, I now have my little inspector, which allows me to quickly add like information about an instance of something. So what it's showing is that we can, with no UI, with no code, basically, we're able to build and deploy web applications which integrate with Google Maps, charting, tables, and trees. There's different statistics, and these become fully interactive as well. Okay, so I can reduce the amount of data that I see. If I don't want to see earthquakes between these guys. So 6.0 and 6.9. Okay, I can start to drill in and I can see where these are. You can also add tables, which are fully like, I want to sort some kind of information and present it to the customer, which is like, I want to add a table. Okay, so I'll minimize that. So I can add a view, and I want to add, in this case, I can say I want a table. Okay, again, I'll drive it from earthquakes. And in this case, I'll select everything again. Okay, so here's my table. So now I want to customize that. So I can go to my definition, my preferences. Okay, I want to say they're interactively sortable. I want to turn the colors off, change the color between 1 and 1. And now I want to sort them on a column. Select the column, and I can say I want to sort it on the number of depths. Okay. So again, I'll run it, and here's my little table. Okay. So now what I want to do is filter that. I want those two to be filtered again. So what I can do, okay, come back to here. You see this little filter guy, I can associate it with my earthquake filter so that it integrates with the slider bars that are hooked up on the left. So now as I adjust the filter, they're fully interactive. So now without any ado, I can just quickly integrate with Google Maps. And so now I can also adjust whether or not I want the satellite view or I want labels. So if I zero labels, it'll show me that I'm inside China, where that giant earthquake happened. So now I'll move on to the second demo, which is our flight logistics guide. And let's see, I'll open up a new project, and it's called International Flights. And in this case, the data we're driving it against is this guy. So we have some flight information, which is like from the USA to some airport, and these two columns are the number of millions of people that are carried across. And this guy shows the links, so Honolulu to Seattle, Honolulu, on and on. So I have a couple of little spreadsheets, and again, I'll just run it real quick so you can see where it is. Okay, so I have a map, and what I'm doing is I'm drawing an arc between my push pins, basically where the location of the geospatial data is located. So I want to see like the coordinate between my international and my domestic flights. So if I click on international flights, so the controls on the left drive the data on the Google map, and it also manipulates the data on the bottom. This graph down here shows the number of millions of passengers. So I can see, if I just want to see my 2012 data, I can remove that quickly by doing that. If I want to see a particular airport, I can zoom into Tokyo, and I can see how things are maneuvering. So it's just to show you like how Google Maps is integrated. But see, a lot of times, like we have both coordinate data, but we also have a lot of connected data, basically graph-based data. You know, in today's connected world, people are generating a lot of connected data, like your Facebook friends networks, your corporate networks, your, you know, communications networks, all sorts of networks. Networks are all over the place. And so Tom Sawyer's main strength is graph theory and graph visualization and graph analysis. So I'll move on to that, and I'll show a quick little demo of a simple demo of our drug trafficking network analysis. Okay. So in this case, I'll go down to, let's see. Social network analysis. Okay. So social network analysis, I'll quickly run the application. And in this case, we're showing a computer network, or a drug trafficking network, where we have, on the left, we have dealers, drug dealers. We have the Don, which is like the head guy, like the kingpin. We have drug suppliers, and we have drug traffickers, and we have users. So I can start with the Don. Anyway, and it's kind of cool because down on the bottom here we're showing like how connected people are. So I can click on the network, and it's going to interactively scroll me across the data and allow me to quickly navigate through my drawing. So we have a little overview window which allows to shows like on the right hand side, which allows you to basically interact with the diagram at the same time when you tie it together with trees, charts, and in this case a bar chart. So we have certain algorithms that are social network analysis algorithms. We have betweenness centrality, we have closeness centrality, and we have degrees of centrality, like degrees of Kevin Bacon game. And then we have eigenvector centrality. If you're not a social network analyst, we have examples that really teach you like what it means, each one of these mean, and how to use them. But you don't have to be the computer geek to really get it. You know, you can. Most people know like how Facebook advises you, like, hey, you might know this guy, or LinkedIn goes, hey, you might know this guy. This is how they're doing it. They're using these kinds of algorithms where they're seeing like a friend of a friend and a friend. They're using graph social network analysis to figure out who you might be friends with. It's kind of creepy because it works. So I'll run a few algorithms and I'll show. So in this case, what we've done is, I'll fit it in the window. So what we've done is we've ran an algorithm and it changed the size of the object depending on how important they are within the network. It's great. It's easy to get a network to populate, but it's hard to do the analysis on it, which is like, okay, I have all this big hairball of connected things. Like, what's so important about it, or what can I learn from it? And the idea is to make sure that you can focus on what's important in the network to see what you need to safeguard, or who needs to be focused upon, whether it be sales or whether it be fraud, or there's different types of reasons why you might be interested in securing something or studying it further. We have different types of algorithms. These are called top suspects in total connections. So I can see who's this Marco Polo guy, or Narco Polo, and he's going to drink me right into the middle. So what's nice is that you can see how these guys are linked together, and so you would only focus in on the top. So again, you know, if you can see who they're connected with, and then you can see that who's this guy. You know, he's directly connected to. So I can look at him and I could get some more information. So if I was the police and I had his, you know, social security or his car number or something, I could check that out and run a query on him and find out some more information. So if I wanted to do an investigation. We have different layout styles and stuff like this, so you can view it in different forms. So this is what we call our circular layout. This is our symmetric layout. I'm sorry, our orthogonal layout, which allows you to route things along street lines, kind of like how the city's laid out. And so I'll drill into the diagram a little bit, but you can see how he's fully important. And he's selected within the diagram. You'll notice like how we're able to quickly and really nicely link together in here. And these interactivity. And the thing is, it's fully printable and all these kind of things as well. Okay, so quickly about the drug trafficking network. So say I'm like a sports guy and I like to keep track of the World Cup. I'll show off a little bit of our World Cup example. I'll close that. World Cup. Okay, and in this case, I'll look at the schema. I have the country who is playing in the World Cup. I have a game, which is an instance of a game, like, okay, who's playing and this kind of stuff. The year it happened, the place, the result, which is like what was the score, the country, the two countries that were playing in the game, and how important it was. Is it the quarterfinals, the semifinals, or the finals? And then a year, a few things like that. So in this case, we have a drawing, which is a graph. We call it, our drawings are the graphs. Trees are like trees, and we have a chart. In this case, we have a filter, and we have two filters. You can filter it on importance, or you can filter it on the game. So I'll quickly run it in our HTML5 previewer. And so I quickly analyzed the data, created the network drawing, populated the pie chart, and created the tree control with zero code. We are fully J2EE app server, so we can be embedded inside your other existing app servers, or we can run a standalone. So I'll go on. So in this case, what am I showing here? So I have the series of years between 1930 and 2014. I'm only showing the last two. So say I'm only interested in what happened last year. So I can click these guys off, and I can see who was playing in the group stage. Excuse me. So we can see the United States, different countries here, and who scored the most goals. So you can see how it, but who cares about the group round? Let's go to the final round. Let's see who's playing in that. So I'll cancel that. So Germany and Argentina are the last two. And it looks like Germany won. So you'll notice here that we're placing data directly inside the drawing as far as like images, textual data, and we have what we call labels, which allow you to place markers or importance upon the relation. Give the user some important information about the relation between them, instead of leaving them guessing. Everybody's like, I don't get it. But the important thing is that if you put labels on your relations, it really takes the mystery out of it. And in this case, we're actually showing a rotated label, because you'll notice the label's off a little bit. And actually I can move it around. The drawing is fully interactive. So let me show, okay, let's see the quarterfinals. Okay, let's include that. So now we have the final and the quarterfinals. Okay, let's see how that relates against the last. Let's keep going back until we're happy. Okay. So you can see that Brazil is really good. Germany is super good. Italy's okay. And so on and on, you can see how they go. So you can see that over the years, you can learn more about like who's really good over many years of time. I will show it as an orthogonal drawing, which is quite cool. And you'll notice how the drawing shows labels that are rotated vertically, horizontally. And again, you can see how Germany is done. So let's take a quick little look about what's the anatomy of this diagram. Because I think most people can do charts and stuff like that, but the diagram is very difficult, and that's really where you can learn about the topology or what's inside the network. I need to infer information from the data I've been given. So I have this big blob of data, and everything is linked to everything else, but I need to infer what's important. So let's see how it's constructed. Okay, inside that, it's just like any other view. I have an action. So if I run into a country, I have a condition, and then what I want to do is I want to add a node. So basically what happens is you say I want a new, and you click here, and you say structural, and you can add a connector, add an edge, add a node label, add an edge label, and so on. And so what this allows you to do is to create elements within the drawing from the data. It's like an ETL transform. Like you're transforming from one format to another, but you're converting it from a flat relational table into a graph model. Okay, so now I want to see a game. So in this case, we're adding an edge between games. So I have one game and I have another game. Well, I have a game, but there's two teams in the game, so I want to create a link between the two teams. So if I run into that, I want to add an edge between the two countries, from the source to the target. So really, that's how easy it is. So it's not like some big, you have to write like big blob of code saying if I find this, none of that nonsense. You just, and all this stuff is generated right from the schema. So we'll like pre-populate it for you. So it's not like hard to figure out. And trees are very similar that way. It's like you have a parent and child. So as long as you know who your parent is, it's easy to populate, and you can do grouping and stuff like that. We also support search within the model, which is pretty cool. So I will show that really quick. I'll probably show it in a better little example. But you'll notice we have a search bar up here. So I should be able to type in Germany. Okay. So I got Germany. I can click on it, and it'll zoom me into the data. So it's great, and it'll support wildcard searches and other kinds of things like that. But you'll notice that we also have it, the data is fully integrated into the pie charts. And we will, what's nice about it is that you don't have to be a rocket scientist to create really cool web applications. Your boss goes, holy cow, this person's worth their weight in gold. And so when you use a product like this, you're not reinventing the wheel, you're not Mr. JavaScript, all this nonsense, because it's really hard. I mean, to be honest with you, a lot of the guys probably in this cafe are probably in the back going, coding away, and it's really difficult. And the amount of knowledge it takes to have the data expertise and the web publishing expertise and the social networking and expertise, you have to be a real superstar. Or you need big teams. And you need a big organization to figure it out. So what we've done is taken the heavy lifting out of it. And it's taken a lot of heavy lifting on our side to do this. So this is just another example. I will show you a little bit more cool one. So that's our World Cup guy. But it allows you to filter and drill down on the data and learn about what's going on inside of it as well. So I'll close this out. Okay. Governance. Governance is what we call, it's SEC data. It shows like how boards of directors are interrelated. So if a person sits on a board of directors on, say, Coke, and a person sits on the board of directors of, say, Pepsi, that's kind of bad, right? You don't want that. It's really a conflict of interest. So, as these corporations go, there's a lot of high-powered people that sit on many boards of directors, and the SEC generally likes to know because they're probably insider trading and stuff like this. So it's very important that they oversee. And sometimes it's not always clear. So I'll go through and I'll show you I'll run the algorithm. Okay. I'll just run it. Okay. So it's populating. Okay, along the bottom we have the corporation names. And on the top we have a very, pretty decent sized graph. And in this case we're showing, we have a degree control, which is like the 6 degrees of Kevin Bacon game. You can turn the degree on and off. So you can turn, I don't want to see people below a certain number of connectivity or a certain number of hops. Like I don't care about his second cousin. I only want to know about who's really close to him. So I can switch this out and I could turn it, say I only want to see 3 degrees. And the drawing will get changed. And so will the number of companies. So I'll lay it out so I can see what's going on. And you'll notice we have an animation framework that just animated so the user can see where they are. I'll bring up my little overview window, and I can zoom around and see who's on there. So we have a company, GP strategies, Scott. Okay, so I have my little network and it's laid out in there. It shows like when the people were there, what the companies were. And I'll lay out another way, which is orthogonal. Okay. So let me do it real quick. We'll switch it back to 1 degree. And let's see. Go back. So 1 degree. And I'll bring up the social network. So you're going to have multiple drawings. You might not just have one view of the network. You might have multiple views of the network depending on what you're trying to infer. So here's another example of our symmetric layout, which shows like how the people are all linked together. This is probably what your Facebook Friends network kind of looks like. You know, you have, like your high school friends, your college friends, your new friends, your girlfriend's friends, this kind of stuff. And so this is where these clusters are starting to come out of. But in this case, it's the board of directors and companies and people that are involved. So I can remove people that aren't directors or officers. So I can remove them out. And the drawing should reduce. And now I don't want to see them. And I want to see only 2 degrees. Again, the drawing will. So what I've done is I've removed the wheat from the chaff. Like, I don't care about them, they're not important. They're either not very important in the network or I don't need to focus on them. So again, now we have our different analysis algorithms. I want to run closeness centrality. And you'll see how the guys in the middle here are very important within the network. And so we have down here we have directors, officers, and other relations. So I can turn things off. And I want to see who's very important. So we can show bar charts over here. So we have this man, John Friedman. Who's this guy? So if you're working at the SEC, you really want to take a look at this guy. He's highly connected, or he must be very important and very powerful. So you want to keep him happy, or you want to keep your eye on him close. There's also this other guy. He's also very highly connected. So I'll clear the results, and I'll do what we call degree centrality. And it's another way. So you'll notice the network has changed. Like the results on the left have changed. It's telling me that some Marshall Geller guy. Who's this guy? So using a different algorithm, I was able to pick out another very important person who's important in this network. Because of using different centrality algorithms, we can really help understand. What it does is it takes other factors into play, like how connected my other neighbors are, not just how connected am I. It takes how connected your other connections are, and it basically weights you out, and it does sorted edges and stuff like this, where it sets priorities and it calculates who's important within that topology. So we have some statistics, and you can have different types of views within the data. So if I only want to see, let's see, only directors. So it starts to narrow down. And so you can turn them off as well. And it just allows you to show like histograms of so again, you see Marshall Geller, and it should zoom me in on it. And then again, if I had more information, I would be able to show what company he works for and who is he connected with. We have a series of controls which allow you to navigate the drawing. What's also cool is we have a full undo-redo model. So now I just want to keep going back. And it's actually very powerful because you can see how, so I can go forwards. Now I want to play it in reverse because I can see really what happens in real time. And kind of follow what's happened into the model as I've moved around. what it does show is that we're able to handle large complex networks, read to the user very proficiently, and the algorithms that you would need to run integrated into the web application without custom coding. It's fully extensible. So let's look at what compromises those drawings. We have this notion, what we call a template. So if I can see, I have two templates. I have companies and I have social networks. So my two tabs. If I go back to my web app, I have two tabs, companies and social networks. So I want nodes on the one side to look like something, and I want nodes on the other to look like something else. So I have two templates. So companies. So what it does is, you know this little guy here? This is your node template. So it allows you to customize what compromises what's in the side, what you display in the node. In this case, we're displaying an image and a name. And so when I see a person within that, I display that. When I see a new person, I put a little star on him. And you can select images right off the disk, or import. We have an extensive library of shapes and stuff like this as well, but you can bring in your own data. You might have logos for the companies that are involved and this kind of stuff. And so when I see a new company, okay, I want to see a star. And then there's a series of customizable rules, like you set the font color, font size, underline, background borders, transparencies, all these kind of things. Here's what your edge will look like. So if I wanted to draw it a different style, I could pop it up here if I want it to be dashed, and all these kind of things, like, you know, like how do you customize the drawing? So person relation. So in one case I have an officer relation I use as a dash line, and another person I have a straight line. So if you see a dash line in it, it shows that it's an officer is related to the company. So it allows me to customize how the view looks. And we have searches again in here. Exactly like that. So is there any questions so far? That's a quick breakdown of like our Perspectives product, which basically what it is a rapid web application developing system that allows you to interact with graph-based data. With the growth of NoSQL, you're seeing a lot of people. NoSQL is compromised of a lot of different technologies, but the one that really seems to be winning is the superset, which is the graph database. You're seeing like the XML database guys, the MarkLogic kind of guys, the document stores like Lucene, and then you're seeing the Cassandra guys and the Hadoop guys, and now you're seeing the graph databases, which seem to be the superset of all those other technologies. You're starting to see a lot of movement in space. Oracle is moving towards, not even moving towards, they're aggressively attacking and defending their stuff with Lucene and Cassandra and graph databases. Because the world is highly connected, and it's only going to get more connected. People are generating a lot of events. Some of our companies we work with do a lot of service event bus work, and we do customized drawing templates and other kinds of things like this, where you can have really highly specialized layout systems. One of our strengths is that the layout system is fully standalone, and it can run without any UI. You know, you can generate, it's an image generation system, but it's also fully interactive with a full undo, redo model, and this kind of thing. So are there any questions so far? All right, this guy first.
Okay, does your service go well with packages or platform like iDraw from your program?
We generally, what we do, we have a very extensive API. Our tool is first and foremost a SDK sort of thing. The Perspectives is to do the heavy custom work, to remove the heavy lifting from an SDK. But when you really want to get super fancy and you really want super fine-grained control, people basically take our libraries and then custom code to them. It's a fully extensible system. So we have a very well-documented system that you can embed in your existing applications, whether they be .NET, JSP, JSF, JavaScript frameworks, or J2EE applications, or even Swing desktop apps. I didn't even show you, but I can run this on the desktop without any code changes. So this is a Swing app that I'm running. So without any code changes, I just clicked and I ran a Swing app. Because what's nice is that it's fully, the data, the presentation layer is separated from what defines the application. So you can custom code to it and you can integrate other graph-based kind of systems into it. You have questions, sir?
Yeah, 2 questions. One is that you directly connect to the access data?
Yes, we can connect to any database that has a JDBC driver, or Access, or SQL Server, or Oracle, and I believe Access has a JDBC driver, which means that there's a little converter DLL that they give you, and you can put it into JDBC. I can show you that really quick. So, like, if I wanted to connect, I wanted to incorporate more data. You can bring in a database, Excel, Neo4j database, RDF, which is a NoSQL type of store. It's a graph database from Oracle. A RESTful web service. So if I want to hook in a web service to the system, I can. And it will fully support JSON or XML. So your XML schemas are automatically extracted. The schemas from inside of your RESTful web services are also supported. So we'll basically crack open JSON, pull the data out, and fully populate the model. You just point it at the web server. So it's pretty cool. And then we have text and XML. You can also custom code your own as well. Yeah, an edge is a graph term. There's vertices in a graph, and there's links. Basically, like we're here together at the same event, so there's a link between you and I. Or you're on my bowling team, and so there's a link because you're on my bowling team. It's just a notion of some type of connection between us. There's all sorts kinds of a friend, or a relative. She's my parents, my grandparent. There's different types of relations, and to the graph it doesn't matter really, because they're really just showing a topology. Basically, you're building a hierarchy. I can show you some examples. We start getting really killer too on some of these drawings that we can generate. But yeah, like if I want, you can create fully interactive drawings, and you can fully interact with it. And so I can create. That's an edge. What I'm doing is I'm creating an edge between. It's because in graph theory. There's this notion of it started from a color graph. So if you took colors and you started taking crayons, and where two colors touch, it's an edge. Not like what's the edge of this? Like when the table ends, there's an edge between like where do I fall off? And that's pretty much I think where the term came from. There's different color theory. There's but they're all graphs under the covers. Like you're creating links between where things touch, and so what you're doing is you're separating. You're creating structure. And what happens is that they become interactive. We have a full editing and interactive editing suite. But I can also do this on the web. I'll show you a couple little examples. We have a full-blown network editor, which allows you, like the IT guy, for instance, to show. I'll quickly show this guy. So I can do an image map, or I can do HTML5. I'll run it really quick. And this will show like a network topology. And so there's I'm an IT guy. I want to see where my routers are, where my switches are, what's going up and down. We have an alarming framework where you can quickly like show that there's something going on in this place. So I can interactively work on this and I say what's going on. So he's critical, and so I can see what's important, and so it basically allows you to fully deal with that. But I can also like add elements to the drawing and create links between them. Where's my edge tool? Oh, here it is. So if these guys were connected to this guy, I would be able to quickly see what's going on. Okay. So I'm actually modifying from a web app the data on the back end, and actually we support full round trip. So any data I'm manipulating here, I can actually write back to my data store, and you can fully, modify it from right inside of here. So I can change connections and stuff like that. So you can do full interactivity and write back to the database using some of the commands up here. So menuing systems, you can control the menus and the context menus and elements within it. So I'll quickly show, I should show some of the clustering actually. I'll go back to here. So I'm going to social clustering. Oh, okay, let me run the algorithm. So, okay. Sorry, I got a lot of windows open. My boxes starting to come to crawl a little bit. So, filters. So, people. I don't know where the grouping went. But you can actually create groups, and we actually support the ability to create groups within the elements. So if we're... Okay. This one's sorry. So that's my network editor. And yeah. Yeah, so if I want to, I can group it by region or location. So it created two groups, and I can lay it out. And then what I also want to do is I want to collapse all. So I want to see a high level view. So I know my East Coast and my West Coast data. So on my network, I have the East Coast and a West Coast side. And so I can quickly, now I just want to focus down on what's inside the East Coast. So I can say, I can go into the child, and then there's my East Coast network. And I can see the hierarchy. And I can interact with it here. So yeah, it's pretty cool. I mean, and I can turn things off. I can turn regions off. So if I want to turn a region, like I want to turn the East Coast off, I can go up. So I can lay out hierarchically. I want to add it back. So what it's showing is that you can slice and dice your data, apply algorithms to cluster the information, and do some more like that. So is there any more questions? I'm actually running out of time. So there's got to be some students that have some questions. Come on, don't be shy. Okay, go ahead.
There's verse bar graphs.
Oh, okay. This
That
one?
one, yeah. Not that part. That one, yeah. Is there a way to sort those?
I believe so. Yes, I believe there is. I'm not the expert on the charting system, but I believe the information you put them in, the order you put them in, it will sort them. Yeah. Yeah. There's a series of controls per view, and what we do is we expose those to you, and then we allow you to manipulate it. We have function libraries like square root and all those kind of functions, and we have we have like functions that you can invoke on the data in real time, so you can invoke it on the client side as it comes in. So yeah, we have a full function library. It's hard to show you every little nook and cranny of the system because but it doesn't take you long to learn. And within a few days of playing with it, we've seen people put together some crazy applications. I mean, super cool ones. Yes, sir?
How do we get to play with this, and how do you license it?
I will bring up the web page really quick. So I'll go over to tomsawyer.com. You can visit our website. We have download trial editions. You can register. You sign into our corporation and you file for an evaluation. You fill out your name and a few little details. And we let you download the system. It does come with a trial license. A lot of enterprises, we have development seats, which allow you to, how many developers you plan on using the system for. And then usually, you know, we talk, generally, what happens. So, I mean, we do power, we are a full enterprise-like scale system. I mean, we have 24 by 7 support around the clock. We have development offices around the world. And so, I mean, some very important customers have trusted us to power their backends as well. Backends and front ends in many cases. Any other questions? Okay, I would like to say thank you very much. I hope it wasn't overkill. I hope everybody enjoyed it. I could go on for hours if you'd let me, believe me. There's a lot of detail to this, and you know, our diagramming engines are super powerful, especially when you start involving connectors and constraint-based layouts. So, you know, we do some layout styles that some people can't touch, and as data has really growing, high-performance data analysis is critical. I mean, it's critical, and it's taken years to master. And so, don't undertake starting from scratch too lightly. We've seen many try and fail. And so what I highly recommend is that you give our system a try, take a look, and play with it. And we welcome your feedback. Yeah, we love working with students. We love working with college programs. And sure, download the trial, and I'm really glad I got to share with you guys. Thank you.